Okay, in this video we will learn about exponential functions. That's the title of this chapter, exponential and logarithmic functions. But we will be focusing on exponential functions in particular in this first section. What is an exponential function? You probably have heard the words before, like the population is, blowing up exponentially, or it's like, rising exponentially, things like that, okay? A function is called an exponential function when it looks like this. A function is called exponential when it has a base that is a number and an x in the power. So this is an example of an exponential function. Another example would be something like 5 to the power of x maybe, or another example would be something like negative, or rather 1/2 to the power of x, let's say. Okay, so those are all examples of exponential functions. Now, when we're discussing exponential functions, we typically like the base, so the 1/2 that's written over here, that's called the base. We like the base to be non-negative. So in other terms, we don't want the base to be negative value. And that's because it makes the calculations a little bit more difficult later on, okay? The other thing that we don't want is the base to be 0. Why don't we want it to be 0? So we don't want it to be 0 because if you have 0 as a base, 0 to any power is going to be 0, and that's it. It's a boring function. It's always 0. It doesn't do anything. It doesn't go up or down. It's always 0. And the other thing we don't want either is the base to be 1. We don't want the base to be 1 because if the base is 1, again, 1 to any power will be 1. And again, that's a boring function. Doesn't do anything. It's always 1 no matter what you plug into it. Okay. So typically speaking, when we're talking about bases, we want the base to be either some random number between 0 and 1. So the a, we want it to be between 0 and 1. Or we want the a to be more than 1. Okay, so those are the two interesting cases that we will be focusing on in this section. And so when the base is between 0 and 1, or the base is more than 1, we get different graphs. And you'll see that in the first table, okay? In the first table, I'm telling you what happens if the base is a number that's more than 1. So if the base is something like 3 or 5 or something, then typically speaking, the graphs will start very, very small and they will expand and grow up very, very quickly, okay? So that's the general shape of the graph. So you'll notice that the function is always positive. It's always above the x-axis. That's what it means to be positive. You'll notice that the function is always increasing. So if I have a little stick figure guy standing over here, he will always be going uphill forever. It's a continuous function, which means I can graph the whole thing without lifting my hand. And, as x gets smaller, the function stabilizes, becomes more and more horizontal. And as x gets larger and larger, the graph becomes bigger and bigger, okay? We say that the x-axis acts like a horizontal asymptote. That means the x-axis is like the border. We can never cross this border, okay? Now, what about if the base is some random number that's between 0 and 1? So things like 1/2, 1/4, 8/9, things like that. Then we will notice in these functions, or these bases, that the function starts very high and it goes down super fast. It goes down quickly and it becomes almost horizontal at the end. So that's the general shape. So when the base is between 0 and 1, you go downhill. When the base is between, or when base is bigger than 1, the function goes uphill, okay? So again, it's the same properties. It's always above the x-axis, which makes the graph always positive. It's a function that's decreasing. My little stick figure guy would be going downhill all the time. It is a continuous function, which means I can graph the whole blue thing without lifting my hand off the paper. And, there's some other properties listed right there. So we're going to begin this first section by graphing some functions f of x. And we're going to do that with a table. So for example, in this case, we're going to be graphing the function f of x equal 2 to the power of x. So the base is 2. This is what we call the base. And in this case, the base 2 is more than 1. So I can expect the graph to have this shape to it. It's going to be kind of like the yellow graph. It's going to start very, very slow and it's going to shoot up very, very quickly. And in order to see this graph, I'm going to be making my table. So we'll do that in another video.